Now, regularization is something where you try to penalize your network. So this is kind of an additional loss term you add. And what you want is you want to have small values for these weights. So what you can do is you can define like a very simple loss term, which is also called like a regularization term, which will ensure like your values for the weights is actually very, very small. So again, this is showing a simple example. So blue curve is overfitting, green is underfitting. And you can see that this, if this is a testing sample, the blue one is completely failing, but the green one is doing good job. Okay, so what we do is, if this is your standard loss function, which is taking data as input, these are network weights, and this function is like the network, which will give you some prediction. You will compare that prediction with the ground truth, and that's like your loss value. And this is your regularization term. You have a parameter here, which controls like how much importance you want to give to this regularization. Okay, again, this is a hyperparameter, and you use like the weights of your network as input. Okay, and this is also called a weight decay. And there are different variations of like of this regularization function you can use. You can use L1 norm, which is nothing but you compute L1 norm for each of your weights in the network. Just take the positive absolute value of that, right? And you just minimize that. So it will make sure that you don't have high values for weight, because if you have high value for weights, your loss value will increase. Okay, so you're trying to minimize these. And I think this also covers, like, I think when we were talking about basics of linear algebra, some of you asked like, what is the application of L1 norm, or in fact, like, what is the application of norm? So this is a very interesting application of those norm values. It doesn't have to be L1 norm. You can also use L2 norm. You can just square those values and try to minimize those. And there are a lot of other variations, but everywhere, like, the motivation is same. You don't want these weight values to be too high, because if you do that, then those weights will actually control what kind of prediction network is going to make. So, and you don't want that. You don't want to control the output of a network by just like some of those weights, right? You want to make use of all the weights to be able to make like a reasonable prediction.